Okay, Sneha, now you can start.
Okay. So, am I audible to everyone?
Yes, you are audible.
Okay, I am presenting my screen.
Yeah.
So, is my screen visible?
Yeah. Now it is visible.
Okay. Okay. So, I will be starting with the some introduction part actually. The introduction to normal probability theory. So, anyone does have any kind of idea about distribution? Like we know about discrete distribution, continuous distribution. Anyone does have any idea? Just a brief one or two liners. Hello.
Okay, no one has the idea. So you start from beginning.
Okay. So, few classes ago, Sir has started a game actually, where he asked us to say the reverse word 100 to 1, 100 to 0, and we someone has noted down the timings, right? The timings were the data points for us. Okay, but just to have the data points, we can't do anything. Like how we can do some visual representation, and just Sarah already discussed about the mean, median, mode, and the cut. I think the SD also, and the correlation. I think also he has discussed already. So we did that much only. But if we have some kind of data points like some heights, so the height of a student, the height of some students of a class, and we just only those type of heights and nothing else we do have. So for doing this kind of analysis about, we have to know that the how the data is going to be fitted. Like we need to know that is it following some kind of pattern, or we need to test something. Like testing concept is a bit higher. I will not discuss it today, but I am just giving you the idea that is it necessary that to know whether the data points are following any kind of uh, like distribution or any specific characteristics, so that we can uh, interpret something. Like is there any testing or any hypothesis which can be tested? So there are two kinds of distribution: discrete and continuous distribution, as we know. Where the discrete distributions, like we can say that like number of pens a person do have. So we cannot have 1.5 pence or 2.5 pence. It must be some natural number, right? Like uh 1 pen, 2 pence, this kind of things. It cannot take any value within its range. Okay. It can take the natural number, and also zero is also included in it, but it cannot take the whole real line, the range as whole real line. Okay, so it is an example of discrete distribution and discrete data actually. And discrete distributions, there are some kind of distributions like binomial distribution. Basically the first example we give like binomial distribution, where 0 and 1, like 0 is the failure and 1 is the success we consider. Like after that, the sum of Bernoulli trials will represent the binomial distribution, then Poisson distribution, and many more we have. In continuous distribution, also we have a good number of distributions, where I would say about the normal distribution. Here, normal distribution is such kind of distribution, if you study in future, using the central limit theorem, any kind of distribution can be can tend to normal distribution. Okay, here the I shared the graph. Is the graph visible to everyone? This portion, or should I move it?
Yes, visible.
Visible. Okay. So here is the graph. This is standard normal distribution graph. What is the standard normal distribution? Like for every distribution, it must have some characteristic. Okay, which will help us to know how the distribution behaves or how we can identify the distribution from the others, right? Like each and every person have some different characteristics, right? We cannot say that this person is a clone of the other person, so we cannot say that, we cannot say like this. There's some unique characteristics among each and every person. So here is some characteristic which can differentiate the normal distribution from the other distributions, and this normal distribution is very much important for us because in future when we do testing or when we do many statistical inferences, usually whatever data we have, we basically assume that it follows normal distribution, as I have already said about the central limit theorem. So we usually assume that. Why? Because it's simply there are many causes obviously, but the simple cause is for the ease of calculation, nothing else. We can get each and every measure easily, when we assume that the data is distributed in normal distribution. Okay, so it is there is another name, that is Gaussian distribution, and we can see that this is a bell-shaped curve, right? And this is unimodal. So how can we characterize the normal distribution? There are two parameters, that is mean and standard deviation. Okay. Is there any, right? Can I write here? Is it possible to write here? Is the whiteboard visible?
It is coming.
Hello?
It is
Hello?
coming.
Okay, okay. Okay. So normal distribution. So we usually denote it as N mu sigma. Okay. This is the notation where mu. So sorry for my handwriting. I am using the touchpad, so it doesn't look good, but you can understand it, right?
Yeah.
Okay. Mean, and this is AST. Usually mu sigma square we write, that is SD square, that is variance. Oh, bad handwriting. So,
This is variance.
yes, variance, mu sigma square.
Okay. And n means?
N denotes the normal, that is the normal distribution. In
Okay.
I am writing the symbol only. How we denote, like if in any book the student can see, then how will he or she identify that this is normal distribution?
Okay. Your PPT not visible.
Yeah, it's not open. Hmm, just a second. Is it okay now? Is it visible?
Not visible. It is coming slowly.
Oh, it-
Now visible.
okay. So I have discussed that what are the parameters, that is the mean mu and the standard deviation sigma. Okay. And I have talked about the shape, that is this is a bell shaped curve. As far as I can remember, before today someone also has pointed out something like the word bell shaped someone has already used. So I think the bell shaped concept is known, right? Why it is called bell shaped. So now I would go to the area estimation. So, in continuous distribution, here I am not writing anything, just listen to these points. In continuous distribution, what we do, like we do histogram, okay, and after plotting the histograms, we do the probability curve, we plot, and the histograms, everyone has seen, right? The histogram, how does it look? Like everyone knows about the difference between histogram and bar diagram, right?
Yes,
Hello.
they know what diagram, histogram.
Okay. So then I am not going to explain it. I am just telling the thing
You go to the slide 2.
that slide 2. Okay. Okay. Here I am discussing the already I have discussed the shape. Then I am discussing about the mode, median, and mean. Here we can see that as the shape is bell shaped, here this is the mode, this is the median, and this is the mean also. Three of them coincide. Okay. It is symmetric about the mu. As it is a curve of standard normal distribution, we know that in standard normal distribution, the mu is 0 and the standard deviation is 1. Okay. That is why it is symmetric about 0. But usually it is symmetric about mu. So I have discussed that mean equal to mode equal to median here. Perfectly symmetric. Anyone can tell me about the concept of symmetricity? Like what is the concept of symmetric about a point? Like symmetric about A? Anyone, please? Are my words understandable? Like, am I clear to everyone? I am getting confused whether are you getting or not.
No, 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 no. They understand.
Okay, that's fine. That here the symmetricity means that this suppose the point 0 there is a mirror. Okay, this is a part of mirror and this is the reflection, exact reflection. Like if there is the data of one side, like 50% data is here, then there is a mirror at this point and the reflection is this side. Okay, that is the layman as about symmetricity. So I have said that this is symmetric about mean, and as it is coincides with mean, median, and mode, so symmetric about mean, median, and mode also. So another property is that this is a asymptotic curve. Like as you can see, if we zoom it, this is not a closed curve, right? This curve, this is not closed. Okay. As you can go through the x-axis, it will never touch the x-axis. It is asymptotic. Okay. It is not closed. Sorry. Yes. So this up to this much is it clear or any question? Anyone does have any question? Okay, moving to the next slide. So what is skewness? Like why do we measure skewness? Skewness measures the asymmetry about the data. Asymmetry of data. Okay, like if the data set, if we have lots of outliers, then the mean is affected by those outliers. Like in the next slide, I have, is this graph visible? These four parts?
Uh-huh.
Like, yes, various type of distributions. Here I have I have shown that the positive skew, negative skew, and the normal, the characteristic of normal I will discuss. Let's talk about the symmetricity. Sorry, skewness. What does skewness means? The asymmetricity. It measures the asymmetricity. If the outliers is there are many outliers, then the tail goes longer. Like if the outliers are in this side, then it goes longer to this side, and then we get affected. And similarly for the negative part also, right? There is the outliers. So again the mean got affected. But in normal distribution, there is no story of asymmetricity. Yes. There is no story of asymmetricity. The skewness is zero here. That is, I have already said that symmetric about mean. So the skewness is zero here, and the mean is not affected by the outliers here. Okay, perfectly symmetrical. No longer tail on either side, as I have discussed about the mirror concept. Equal distribution of left and right, symmetric bell curve, and right and left are similar. You can understand from the mirror concept. So I am not discussing it again. Next, come to the kurtosis part. So kurtosis measure the pickedness or the flatness. So how the picket the distribution is? Like we have the data and we are measuring the pickedness of the data set or the data points. We have plotted the data points and trying to plot or fit some graphs with some graphs or distributional card, and we want to know how picked the data set is. So here the normal distribution is mesokurtic. That is neither too flat, this one is platykurtic, that is too much flat, neither too high or too piqued, that is leptokurtic. it is mesokartic. That is normal. This is mesokartic. And where the excess kurtosis, there is a formula where the excess kurtosis is 0 and the kurtosis is 3. Okay, the excess kurtosis part is just adjusted with the formula of 3. That is why this is 0 and the kurtosis is 3. Interpretation, that is, I have already told, moderate peak, neither too flat, not too sharp. And I have discussed the three type of kurtosis, the leptokurtic, mesokurtic, and platykurtic. Hope you have understood all of this. Up to this, any question? Anyone?
No, ma'am.
Okay. So area under the curve, like I'm just presenting the whiteboard again. Whiteboard is visible? It is visible, right?
Yes, ma'am.
Okay. So, what I have discussed earlier, that suppose this is our x-axis. So is our y-axis. We are plotting background. Like this kind of, it is not bell-shaped, obviously. Just a second. Trying to do something bell-shaped, whatever. So here we have the histograms. Okay, we have the bars. So does anyone have any idea about area under the curve? We have already studied in class 11, 12. We study this kind of things. Like this kind of bars under this curve, we measure the whole area. Okay, it is applicable for continuous distribution only. And we do this kind of things like we do integrals, right? The integral concept is basically based on the area under the curve concept. Like what we do in integration, we usually measure the area under the curve. Okay, that is the integration. Like we are just drawing this kind of the integration sign and giving the range that 0 to 1. That is not the thing that we are just blindly doing integration. It's not. It's actually area under the curve. So same concept is here also. Here we are doing this thing in terms of probability. Like we are presenting the area, but where we consider that sorry. Is my screen visible? Hello,
Ma'am.
visible or not?
No, ma'am.
No. Okay. now?
Hmm.
Okay.
Yes, ma'am.
So here we know that the range of the probability is what? 0 to 1, right? So under the curve, the whole area is considered to be 1, where the area represents the whole probability. The curve is divided into equal two parts as about the mean. Okay, that is the 50%, 50%. From the mirror concept, you can get it. That is half of the probability at right side and half of the probability at left side. So it is similar. I have included one more graph. Here is the area estimation I have considered. This represents the mean mu. All of you can see this part, or should I
Yes,
zoom
ma'am.
it? Okay, fine. So here is the 3 sigma rule. Okay. So what is the 3 sigma rule? Like here is the mean. When we know that this is symmetric about the mean, the bell-shaped curve, just deviate, like we are deviating from sigma, like we are adding sigma from both the sides, plus sigma and minus sigma. Like sigma, what is sigma here? SD, right? I have already said sigma square was variance and sigma was SD. So we are adding plus sigma to this side and subtracting sigma to this side. So this portion, this includes the 34.13% of the area. And the whole part, the interval, whole this interval, the dark blue shape, dark blue colored, this portion is 68.26% of the area. Okay. We can say like confidence interval, we can say kind of interval when we will be dealing with testing kind of things, then we will understand this better. We are getting some interval. Forget about this part. Only this part is contributing the 68.26% among the whole 100%. Okay. Then 2 sigma, like we are adding 1 sigma more to this side and subtracting 1 sigma more to this side. Then the whole area, like the dark blue part and the sky blue part also, whole the area contributes 95.44%. Like as you can see that this part is symmetric. That's why this part is also same. Like if you have any kind of questions, like in competitive exams, we are given some kind of questions, like some shaded part is given and we need to calculate how much portion is this. Like this part is given and they are asking for this part, the area of this part. So this is a trick, basic trick. They are giving the applying the 3 sigma rule only and nothing else. This part is given. We know that this whole part is the mirror reflection of this. Then we can easily get this part, nothing else. And the same way, we are adding sigma again. And this is the final interval, that is 99.72% of the total area is covered here. Why can't we get the total 100%? Because I have already said that the curve is asymptotic, like it is not closed. So how much sigma you can add or subtract, how much you can do, you will never get the 100%. It will be 99.72% and it will increase, but not 100% exactly. So some practical interpretation, like I have already asked in the beginning, that the height, weight, marks, IQ scores, This kind of things are example of continuous data, and whenever we do testings or such inference things, we consider that this kind of data follows normal distribution. So, and I have when do we use this kind of data? Like in statistical quality control, psychology, you people will know better about psychology from me. Like I am not a student of psychology. I just know how to apply a little bit. And economics, like some parts, nothing much. I'm just noting down this kind of things where we can use this. Why it important? Because helps estimate probabilities basis for many statistical test visual that I have already discussed. That whenever we do testing, we usually assume that the data set is tend to be normal. That is, here is a real life example that the distribution of height of adults women, is this picture visible, this one? Hello.
Yes, visible.
Okay, so there is an example that distribution of height of adult women in US. So here the parameters mu and SD. Mu is considered to be 64 inches and SD is 2.5 inches. And again, the 3 sigma rule is applied. Nothing else. The part, as I have already discussed, the divisions, this same thing only. I have just repeated, nothing else. Up to this, any question, any query? Any
Acha,
confusion
related to 1.96 and 2.58, please.
related to, sorry,
0.05 level and 0.01 level of significance.
okay. I am after completing these slides, I am discussing that.
Acha, okay.
So, what is our summary? So, whatever I have discussed, I have just noted it down here. And please make a note of this. Like, whatever I have said, all those things, everything is not required for you. I am giving you 2 minutes. Just read it down and write if you want. Just giving 2 minutes. So anyone, any query, any problem, please feel free to ask. After that, I will be moving to another concept, that is the level of significant concept. Any doubt if you have?
They have understood.
Okay. Okay. So moving to the next part. This part is not in my slides. I have not noted it down. So I am just telling the concept. So what is level of significance? Okay. So usually we note it like using alpha. Okay. This is a threshold. This is kind of a threshold which is used to determine whether a result is strong enough to reject the null hypothesis or not. What is null hypothesis? Like which hypothesis we have to test. Like in the previous example, Like here the mu is 64. Suppose we have to test whether the mu is 64 or not. So our H naught, that is null hypothesis, will be mu equal to 64, and our alternative hypothesis can be anything like mu greater than 64, mu less than 64, or mu not equal to 64. It can be anything. The assumption that nothing special is happening and any observed effect is just due to luck. Just whenever I test the null hypothesis, what is our assumption? That we are assuming, suppose we are claiming that the null hypothesis is true. That is, mu is 64. The think of is as risk of tolerance for being wrong. Like, how much can we be wrong? That how much the threshold can be when we say that no, our assumption, our null hypothesis is wrong. So there are, I am giving some definitions, not definitions, some concept. Just remember it. Nothing to take so serious. Just remember it, and you will learn it later. In the next courses, we will be learning this. Level of significance is the probability of committing a type 1 error. What is type 1 error? Rejecting the null hypothesis when it is actually true. So, in simple words, what we can say that it is the maximum risk you are willing to take of concluding an effect exists when it actually doesn't. That is false positive. We are rejecting the null hypothesis when it is true. Okay, that is true means that is positive, but we are rejecting. We are thinking that is false. Okay, that's why I am using the word false positive. So how it works? Before conducting a study, researchers set the level of significance. That is like significance level is 10%. Significance level is 5%. Is 1%. Like if it is 10%, I will say that the researcher is very like casual kind of a person. Like he allows a good number of errors, I would say. Like if the significance level is 5%, he is a bit strict. He won't allow this kind of errors. So, and if it is 1%, then he needs the 99% accuracy, 99% confidence interval. That is the most strict, I would say. Like it depends on a study actually, and obviously on the research, upon the researcher's thought process. This acts as a cutoff line for the p-value. What is the p-value? P-value, the probability that your results happen by chance. If the probability, if the p-value is less than alpha, the result is statistically significant. That is, you reject the null hypothesis. Like here our null hypothesis is mu equal to 64. If our p-value, after doing the testing, after getting the p-value, if it is less than alpha, what is alpha? I am considering is 0.10. That is level of significance is 10%. If it is less than 10%, less than alpha, then we say that it is statistically significant. That is, we need to reject the null hypothesis. If the p-value is greater than equal to alpha, the result is not significant. You have to you have to be failed here. You will fail to reject the null hypothesis. That is,
Just Sneha, we
yes.
are following 95% and 99%. Huh?
Okay, okay.
So
Okay.
95% means 0.05.
0.05,
That
yes.
is our cutoff point.
Okay.
0.05 and 0.05 less. Then
Okay.
it is significant.
Okay.
So
Uh,
like that.
okay, I am giving the example for 10% alpha. As Sir has already said that our goal is not to get the 10%. We are considering the significance level is 5%. That is 0.05. That is the value of alpha is here 0.05. We need the 95% confidence interval here. Like if I give some example, just an interpretation, I would say the industry standard is 95%. The most common in social science and business that Sir has already said that 90% is like a bit casual, like lower evidence required or not that much serious. But in 95% and 99%, it's high stakes research, like in medical trials, like in psychology, whatever you are working with, the errors must be less. Okay, so the concept, visualizing concept, I would say, in a normal distribution curve, the level of significance represents the rejection region in the trials. If your data falls into the teeny shaded area, like uh, just a second, let me show the previous slide. This part, the 2 sigma 3 sigma rule I have discussed. The rejection, if your data falls into the teeny shaded area, it is so extreme that is unlikely to happen by chance. Like I'm giving an example. If you set alpha equal to 0.05 for a new drug trial, okay, suppose you are testing for a drug and you are given that the alpha is 0.05. You are saying I am willing to accept a 5% chance that I will claim this drug works when it actually doesn't. Like it might happen, na, that the drug is working for some people but not working for some people. But you are taking the error that you will accept only the 5%. And it might happen that for some cases, the case is so sensitive. So in that cases, we have to take the 99% confidence interval, when you can allow only the 1% chance, only the 1% risk you can take. And that is the concept of that p-value, and how would you reject or how would you accept with the basis of p-value and alpha. And the shaded part I have already discussed, how the confidence interval, how the region is shown here. Is this part okay? Is the concept of this p-value, level of significance, is this clear? Like, yes, I have not discussed it in great details. I have just given some overview. Is it understandable? Like, any questions?
Students, any question you have?
No, ma'am.
Good.
Okay, so they have understood.
Okay. Okay. Then, is it is there any part should I give any such explanation, or like I will be giving an assignment today, and it is needed to be submitted by 13 January, right? Ushmita ma'am, is it 13 January, or I forgot the date?
Yeah, 13 January.
Okay, 13 January. Yes. So I think the questions will be easier. Like the concept I have discussed, the questions are much easier than these parts, I would say. Like you can answer it within 5 or 10 minutes. So I think my part is done for today's session.
Okay, thank you, Snehal. Now they have the examination.
Okay.
So from 9, there will be the examination. So, and today you have covered the normal probability curve and finally the level of significance.
Yes.
You have covered the skewness, kurtosis. That is good.
Yes, the characteristic I have covered.
68, 95, 99.7 rule. Which is also good.
Yes. So, do I need to give the PPT to them or fine the noted the point, or should I give the PPT?
As you
PPT.
like.
Okay.
Okay. I don't have any problem to share this.
You can share it to Osmita. Osmita will distribute.
Yes, sir.
Okay. That is.
Hmm.
Okay. Then the question paper, that is the assignment I should share with Oshmita ma'am, right?
Correct.
Okay. I will be sharing by tonight.
Sure. Okay. Thank you.
Okay. Thank you.
Thank you, Sneha.
Thank you.
Where are the other students?
স্যার গ্রুপে
Pravnin
বললাম
kahan hai? Where is Pravnin? Indrajit, Pravnin.
স্যার গ্রুপে বলেছি স্যার যে 9টার থেকে স্টার্ট হবে এক্সাম।
ওই জন্য ওরা একটু ওয়েট করছে।
মানে আমি জাস্ট এক্ষুনি বললাম যে 9টার থেকে স্টার্ট করব, বাকিরা কোথায়, এরকম করে মেসেজ করলাম। আশা করছি স্যার জয়েন করে নেবে।
হ্যাঁ জয়েন করে, সিনসিয়ার জয়েন করে যাবে।
স্যার 9টা বাজলে আমি ফর্মের লিঙ্কটা এখানে শেয়ার করব। হ্যাঁ।
কতক্ষণের পরীক্ষা এটা?
স্যার 1 ঘন্টা।
তো 10টায় তুমি খাতা নিয়ে নেবে।
হ্যাঁ।
শ্যামাশ্রী ছিল তো এখানটায়, কোথায় গেল, বেরিয়ে গেল, আবার আসবে।